I'm going to go through a few concept questions dealing with wave interference, just the generic interference, talking about perfect constructive and destructive interference. So again, answer on your own first, then watch the solution. So what do you think about here? The correct answer here is C. When we talk about constructive interference, we can say that the difference in distance the waves travel, since these waves are emitting, the speakers are emitting the same waves, and I assume in phase initially, the difference in distance being delta x, if that's equal to a multiple of a wavelength, then we get constructive. If it's equal to a multiple of half a wavelength, we get destructive. So in this case, we're thinking about how far these waves, so XA is how far these sound waves travel from speaker A to this donkey, and then how far these sound waves travel from speaker B to get to this donkey. They're telling us they interfere constructively in this initial condition. Delta X here, we mean just the absolute value between the difference between the distance those two waves travel. So initially, before we move either speaker, delta X is 0. They're the same distance away. They're both 200 meters, for example, to begin with. So now we move speaker A, we move it back 2.5 meters. So the distance from speaker B is still 200 meters to the donkey. The distance, though, from speaker A to the donkey is this 200 plus the 2.5. Sorry, getting a bit of a lag. So 202.5 meters. Delta X is the absolute value of the one distance minus the other. So delta X is that 2.5 meters. The sound from speaker A now has to travel 2.5 meters farther than the sound from speaker B to get to the donkey. So what we have to do now is we have to see which condition this satisfies. Is 2.5 meters equal to m lambda, or 2.5 meters equal to m plus 1/2 lambda, or neither one? Now remember, m is restricted. It's a multiplier in both of these equations, and it's restricted to being 0, 1, 2, 3, 4, 5, so forth. So what we need to do is we take this value of the wavelength and put it in here. So 2.5 equal to m times 1. When I plug that in, I find that m would have to be 2.5, and that is not an allowed value, so we definitely do not have constructive interference. So it cannot be A, because A, constructive, means it would get louder. Destructive interference. So we have our 2.5, we have our wavelength of 1, so 2.5 m plus a half. If I subtract the half over, I find that m would be 2. And that is an allowed value. So that means this particular situation is destructive interference. Destructive interference is when the displacements are opposite each other, so they add up to be 0 overall displacement of the medium. In terms of sound, we would not hear that sound. Now, to have that intensity go perfectly to 0 means that those are the only 2 sound waves we would hear. There would be no reflection, no sound coming from any other direction. But in this case, C is the correct answer because we get this allowed M value under the destructive situation. All right, we have another question here. What do you think about this? Correct answer here is A. Maxima means constructive interference. Minima means destructive. At this point A, the sound waves travel the exact same distance. So x1 and x2 will be the same distance. Since delta x is the absolute value of the difference, that's 0. Well, constructive interference is the only one that has the m of 0. That also is because the waves are in phase as they are emitted from the speaker. So if they travel the same distance, they will still be in phase. So A is correct. So one more question. If I've done my math in my head correctly, which we'll see in just a second, point B is a minimum. So point B, again, this is similar where we have to see which of these situations, if either, give us an allowed M value. So this is constructive, this is destructive. So delta X is the difference in distance. So speaker 1, x1, this distance from the speaker to point B, since this is a distance of 3, this is a distance of 4, x1, write it at the bottom, is 5 meters. x2 is the distance from this second speaker to that location, that's the 4 meters. So delta X is the difference, so just 1 meter. And so that's what we're going to plug in for delta X in both of these situations. The wavelength comes, we need to calculate that because they give us frequency and they give us the speed of sound. We know frequency is speed over wavelength, which means wavelength is speed over frequency. So 340 over 170 is going to give us a wavelength of 2 meters. So that's what we're putting in for lambda. So in the case of constructive, if I solve for m, I get 1/2. And that is not an allowed value of m. M can only be 0, 1, 2, 3, 4. 0 or a whole number. In the case of destructive, if I divide the 1/2 over, I find that m is 0 in this situation. And this is allowed, so destructive interference is correct. A minimum is a way to describe a location of destructive interference. So m equals 0 would be the first location. So if this was us walking from point A to point B would be the first place we get to where the sound would go down to 0.